Okay. We're going to, so this section, angles and circles, we're going to be doing today and tomorrow. Okay, so we have the double today and tomorrow we'll finish it off. So there's a few notes to take down. So first of all, for the notes, will you please take down these diagrams, okay, and make sure you know what the circumference is, what the diameter is, what the radius is, what the center is, what a semicircle is, and to be honest, those are pretty much a given. A chord, a tangent. So a chord is going from one side of the circle to another side of the circle, straight line. A sector is like a slice, and an arc is here. Okay, so if you take down that, and then what we're going to do after you've got those taken down, we're going to look at some things that you need to know about finding angles within circles. When there's things drawn within circles, how we find certain angles. Like you'd know that angles in a straight line equal 180, angles in a triangle equal 180. But in circles there's certain rules as well. Okay, so once you've got those 6 down, we're going to go through 1, 2, 3, 4, 5 other rules that we're going to take down today. And again, it is the double today, so there's a few notes to take down and then a few questions, and then we'll continue on this tomorrow. Okay, so just bear with me one sec. Right, so there's going to be 5 of these little sections to take down, and in each of them you'll have a circle to draw. So the first one is that the angle in a semicircle is a right angle. So we'll be taking down all these notes, and please understand them. That means if I have a semicircle and this is the base of my triangle, if I draw any triangle that touches the circle at one point, so if I draw the circle or the triangle to there, it would form a right angle. That's the center, obviously. Any triangle, if I drawn, say, well, I'll just show you the bottom one. If I drawn a triangle, I'll do it in red, to here, and drawn it from that to, that is a right angle. Okay, so any triangle that is made using the semicircle, so using the diameter and a point, is a right angle. So that's 90 degrees. Okay. Next one we're going to do is an angle subtended at the center. So subtended just means that it's made by straight lines. So if I make an angle at the center, so say pick these 2 points and attach them to the center. Okay, and then I use the same 2 points and I pick any point. So let's pick say this point here, and I draw them up here, and I draw that one down to there. What it's saying is that the angle at the center will be double this angle in here. So if that's x, that's double it. Look, they've drawn a line from here to the center and here to the center, and when I draw from the same points to somewhere else on the circle, now that point could have been over here, could have been over here, this will be double this. Okay, so that's the second one. Again, I said there's going to be 5 of these, so take your time taking them down. Right, the third one. All angles at a point of a circle standing on the same arc are equal. Okay, so I'm saying here, say if I start with this point and I draw a line to here and a line to here. I've created this angle, haven't I? And I go and from the same 2 points, I draw to another point in the, and I join this one up here. Doesn't have to go through the center. That angle is equal to that angle. And also the same way, if I turn that upside down, these lines have drawn to here and here and here, so these 2 angles are equal as well. And obviously you'll know that these 2 angles are equal because they're opposite as well. Okay? So these 2 angles are equal and these 2 angles are equal. Right, next. The opposite angles in a cyclic, that's cyclic quadrilateral add up to 180. And a cyclic quadrilateral just means the quadrilateral is drawn, any quadrilateral, four-sided shape, drawn and each of the points touches the circle. So it doesn't have to be a parallelogram, doesn't have to be a square, it can be any quadrilateral. And it means that A plus B equals 180. And if we have C and D, C plus D equals 180. Again, you don't know what they are, but if they touch the side, they're cyclic quadrilateral, so they add together to give us that. Alright, we'll go on to the last thing I want to take down. Okay, the fifth one we're going to look at was mentioned. It's not specifically stated like as important to the other, but it was mentioned here, saying, note, many of the problems dealing with angles and circles will involve identifying isosceles triangles. So I've just made a fifth one here. When a triangle is formed using radii, it is isosceles. So what I mean by that is, say if you have the centre of the circle, and I draw a line here and a line here, and I make it a triangle, what can I say about that triangle? I can say that that is the radius, so that's also the radius, so it's an isosceles triangle, meaning those two angles are the same. Okay, those two angles are the same. And if I did that with any triangle using two radii, it would make me have an isosceles triangle. Now there is a certain point where it will become equilateral if all three sides are the same, but unless they state that, you can't assume it, but you can say that it's isosceles. Alright, so we have the notes. Like I said, it's the double. So we have the notes here. Take down, make sure you know what all they are. Most of you should know. The 5 points I've gone through, so take those down. And I'm just going to do a quick couple of questions as examples. Alright, this example here. It says, it obviously has a circle and triangle, so what we've been dealing with. And it wants to find certain things out. Wants to find OBC. So OBC is OBC. It wants to find this angle here. Now again, using the knowledge that we've just had from those 5 things, we should be able to say that this triangle on the right, if we ignore the triangle on the left, this side is equal to this side, meaning that and that should be the same thing. So this should be 65 degrees. Okay? So the answer to that one is 65 degrees, because we've just said that that's an isosceles triangle because it's formed using two radii. Now, before I move on and actually look at the last one, if that's 65 degrees in here, what do I know this one in here to be? I know that one to be 25 degrees, because this one has to be 90 degrees, because remember it's formed using the semicircle. So I've just put that in. So now let's look. And if that's 25, this down here also has to be 25. Again, I don't know what they're going to ask me yet, because again, it's another triangle formed using isosceles, so that side is equal to this side. Okay? So AOB, so this in here is equal to oh, I see. They did it a bit differently in the book. They did it. They found 65 and 65. 130. They found this to be 50, so they found this to be 130. That's fine as well. But the way we've just done it, we found that to be 50, so it must be 180 minus 25 plus 25 equals 130. So there's more than one way to do this. I was looking at it a different way. And again, so find OBA. So OBA, well, that's 25. We've just worked that out previously because it's 90 take away 65. So there's different ways to look at these. Okay, so that's one question done. 2 more examples. It says find A and B in this top one. So this is the one where, look, this and this are both coming from the same point. They're both in the same arc. So this in here has to be the same as that. So that's 48 degrees. And then B is easy. You could, again, if you ignored that and just worked with that, or ignored that and just worked with that, you can see that B is at the center, that's at the circumference. So B is equal to 2 times 48, which is 96 degrees, because it's twice that. Okay, so sometimes these are easy to see, sometimes they're not, so we'll see here. Next one, last example that we're going to do today. ACB, we're looking for this angle in here. Now if we ignore, again, sometimes it's about ignoring some parts. This angle here is at the centre. It's going to be twice this angle. So this angle here will be 40. 80 divided by 2 is 40 degrees. And then ADB, this angle here, now a big mistake, people will say this and this should add up to 180. No, this isn't a cyclic quadrilateral. But if you ignore this middle two lines here, we do have a cyclic quadrilateral. So this and this should add up to 180. So 180 minus 40 is 140 degrees. And that's the final answer for that one. Alright, so we've got through quite a few notes there. A couple of examples. I'm going to give you a few to try. I'm going to come back, ask questions hopefully if you're unsure. And then tomorrow we'll do a couple more examples and we'll finish off on circles and angles tomorrow. Okay?